Hi and welcome to the video on implementing logistic regression using Scikit Learn. I am Raghavendra, an expert in AI, ML and data engineering. In this video, we are going to solve a binary classification problem using logistic regression. And we are going to use the Scikit Learn library to implement the same. In this demo, we have to predict whether a visitor on the website is going to click on an online advertisement or not. We have certain features of the visitors of this website, and based on these features, we will have to predict whether the person is going to click on that online advertisement or not. This is a binary classification problem where the labels are either clicked or not clicked. So let's proceed in this video. We start by importing all the necessary libraries. So we have our usual pandas, numpy, matplotlib, and we also have some of the scikit-learn methods. To check the accuracy of the model, we have the accuracy underscore score, and we as well have the confusion matrix. And for splitting the data for train and test sets, we have the train underscore test underscore split method. So let's start with importing this data set. We have this data set over here in a CSV file called advertisement.csv, and we are importing it into a pandas data frame using pd.read_csv method. Next, let's quickly check the shape of this data set. So we have 1000 rows of data and we have 10 columns. Here is the preview of the data with all the columns. Next, let us quickly check the basic information about the data set to check whether we have some missing values or not. So as you can see over here, we have all columns having no null values. That means we don't have any of the features with missing values. For the sake of simplicity, we shall be considering only the numeric columns in this demo, and we shall be dropping the non-numeric columns. To do this, we have created a list of all these columns, so we will be dropping these columns, add topic line, city, and the country. And what we can simply do to achieve this is we say that data.drop and pass the list of columns to be deleted. And remember, whenever we are doing this in pandas, if we would want this to reflect this in our original data frame, we either have to do in place equal to true, or we will have to assign the outcome of this method to the original data frame. Let us quickly check the preview of the dataset after performing this operation. Yes, we have these three columns being removed from our original data frame. Next, we shall be renaming the columns of our data frame. We can see that the name of these columns are pretty lengthy, although they are very informative. But let us rename them quickly. For daily time spent on site, I just want to call it as daily time and so on. This makes the task a little bit easier going forward. So what we have over here is the list of all the columns. We just assign this to data.columns, which renames the columns in our original data frame. We can as well quickly preview this once again after this operation is done, and yes, the columns are being renamed. We still have one non-numeric column in our data set, which is the timestamp. We will extract some features out of this timestamp feature. So you can see that in timestamp we have the exact date, month, year, and as well as we have the information about the time. This column captures what hour, what minute, what second this particular ad was being displayed. So in Pandas, we have a set of built-in methods using which we can extract these additional features from the timestamp. To do this, we will first convert the timestamp column to date-time data type and assign it back to the column of the data frame. So the next lines of the code will extract all these features out of the timestamps. So we have dt.month will extract only the month feature and store it at column month. dt.day will extract the day and store it in day_month column. dt.dayOfWeek will extract the day of the week and stores it in day_week column. And dt.hour will extract the hour of the day and store it in the hour column. Here, month, day month, day week and hour will be the new columns which will be added to the data frame. And once we are done extracting these features, we do not need the column timestamp and we shall be dropping the same. Let's preview the data. So now you can see the column's timestamp is being removed and we have all these additional new features being added to our data frame. So we have month, we have day month, we have day of the week, which is encoded with values 0 to 6 for Sunday, Monday, Tuesday, etc. And then we have the hour of the day. Next, what we are going to do is to create an independent and dependent variables. For that, we are going to create variables x and y. Now, remember the y over here, or the dependent variable is clicked and all others are the independent variables. X will comprise of all the features and y will comprise of the target. X and y are nothing but the copies of the original data frame comprising of features and the target respectively. The next step is to split this particular data set into training and test set. We obtain arrays xtrain, xtest, ytrain and ytest using the method train_test_split from Scikit Learn, and will pass inputs x and y, and we'll keep the test size as 0.25 and random state of 33. We need to next fit the logistic regression model. We will make the predictions and then calculate the accuracy score as well as the confusion matrix. First, we shall create an object instance for logistic regression and call it as logar. Call the fit method on the object to train the model by passing the training samples of xtrain and ytrain. Let's ignore the warnings for now. Now that the model has been trained, we shall be using it to make predictions. We are going to use this to make predictions on the test dataset. We shall call the predict method on this trained instance and pass xtest. The outcome is saved in ypred, which is going to comprise of all the predictions made. So this is how you make predictions from the model that you have trained in the earlier step. When I execute this, the variable ypred will have all the predicted values for our testing set. And finally, what we will do is we will calculate the accuracy score for the test set. So I have the actual values of the test set in ytest and then the predicted values in ypred. I'm going to pass these ytest and ypred into the accuracy method. When executed, we have an accuracy of 89.2% for logistic regression model that we have created. Remember, we have not done too much of pre-processing of the data, and we have just extracted some features from the timestamp column, but still we are able to achieve a good amount of accuracy of 89.2%. Next, we will also display the confusion matrix using the method confusion_matrix by again passing the y-test and y-pred. So this is the confusion matrix, which gives you a summary of the actual values against the predicted values for the two classes. This is how you can implement logistic regression using Scikit Learn and obtain the performance metrics of accuracy and confusion matrix. Thanks for watching this video.